Welcome everybody to the third session of our technology track. I'd like to introduce Dr. Doug Plata, who founded the Space Development Group. And we are having two sessions this afternoon on the wisdom of using the moon as an intermediary step to going to Mars. Dr. Plata will commence that discussion, and then later today at 3:30 we'll have another presenter on that. So I'm going to turn this over to Dr. Plata. Thank you very much for coming.
Thank you. Okay, so my topic is the moon, a stepping stone to Mars. And when I submitted it, it was printed as the moon, a stepping stone to Mars. And I said, wait, let's put a question mark at the end because it changes everything. Is it a stepping stone to Mars, okay? So that's the question. So, you know, in speech class in college, remember they said, tell them what you're going to tell them, and then tell them what you told them. So I'm going to tell you a little bit about myself because it's actually relevant to this presentation. And I'm going to briefly describe sort of my different positions in terms of space development. And then we're going to get into this question of going to the moon before going to Mars, especially the deep space gateway, whether lunar ice, there is ice on the moon, whether that really should be used as propellant for Mars, whether that's a good thing to do from a policy standpoint, technical standpoint as well. And then also, do we need to go to the moon to get experience before we go to Mars? And then I'm going to go ahead and conclude by describing what I'm doing as a space advocate to try to affect space policy for the current administration. I'm doing some really sort of unique things, I'm sure you'll agree. And then I'm going to make an appeal to you as Mars advocates to not just sit and wait for space policy to happen, because it's probably not going to be good for Mars, is my prediction. So let's jump into it. So let me tell you about myself. I am a physician 60 miles east of here, a place called Loma Linda. You know, people saying, physician, what are you doing at a space conference? Well, I'm a space nut now. I wasn't 5 years ago, but I've since very much become one. Fundamentally, I am an advocate. I'm not Moon, Mars, or Leo, or whatnot. I'm really fundamentally a space settlement advocate, and that's my starting point. And then as I have looked at the advantages and disadvantages of the different approaches, I have come to the belief that we should go to the moon and Mars simultaneously in a particular sort of way, okay? In particular, for this presentation, I believe that we should go to the moon, but it's incredibly important to do it in a very cost-effective sort of way, and I'll describe how that can be done. I literally believe that we can establish an initial permanent base, which is an initial little settlement for between 5 and 7% of NASA's budget using public-private programs. I believe that is reasonable, actually. And then I'm going to end by presenting about a specific event that I'm going to be doing at the launch of the Falcon Heavy in early November, okay? So let's talk about the political situation. I'm sure you all have sort of read the space news, and you know that there has just been an announcement. Jim Bridenstine looks like he's going to be nominated has been nominated for NASA administrator. And frankly, as I look at the news, it seems to me as though the moon is back on the agenda after an 8-year hiatus. But think about how this plays out. We're spending $3 billion a year on the SLS and Orion. We're continuing the International Space Station, about $3 billion a year. There's serious consideration of establishing a lunar gateway. It's on the plan, the current plan. That's going to cost a lot of money. We're going to be burning a lot of dollars swapping crew on that. And the international community, they want to go to the moon, and we're going to be influenced to probably go ahead and do that. How does all of this affect going to Mars in the near term? I think it's going to be difficult to be able to go to Mars from a government NASA budget standpoint. Also, if you take a look at some of the players involved, Bridenstine believes we should go to the moon first. Scott Pace has said the same thing. Charles Miller, most definitely. Walker, Representative Walker, is probably the main current architect of the space policy for the Trump administration right now. He's advocating going to the moon first. And I declare, of all people, Elon Musk, about a month ago, came out and said, you know, it would really excite the public if we were to establish you know, something on the moon. Elon Musk, okay, I think he's seen the political winds, and I think that's why he came out with that statement. I think it's rather telling, okay? Charles Miller, if you're familiar with him, very powerful in terms of space advocacy in many different ways. He got $100,000 to do a study called the Evolvable Lunar Architecture, in which he proposed, his organization proposed, establishing propellant production on the moon, and it came out an estimate of $50 billion. Okay, you can't continue the journey to Mars and have a $50 billion bill that gets in the way. It's going to delay going to Mars, okay? And Charles Miller was on the transition team for NASA, okay? Now, under Bolden, he made, well, Obama made this statement about, you know, we've been to the moon, Buzz has been to the moon, there's other things to do, so the moon became verboten, okay? I am a lunar first advocate. And when this happens, it's just like press the hold button and nothing's done in regards to going to the moon, okay? Now we're getting a new NASA administrator, and the question is are Mars advocates going to be finding themselves out of favor for the next 4 to 8 years, okay? It really could happen, I believe, okay? So here's my positions to be clear. As a lunar advocate, I'm hoping for support from Mars advocates, because if we are headed towards the moon, and if we develop it in a very expensive sort of way, Mars gets delayed. I think that's almost inevitable. And so I have a specific proposal, a public-private partnership, in which the moon can be developed, and I believe there would be plenty of money left to go ahead and continue a path to Mars without a significant reduction in the Mars budget, because of it would be so cost effective to develop the moon. So the idea is to use, for the moon, exclude the government rocket being spent on the moon, okay? Let's have a Falcon Heavy based architecture. And let's go ahead and use United Launch Alliance's idea of a cryogenic lander, which would be a modified Centaur upper stage. And let's go ahead and establish a small permanent base. I have a concept for what I call a unihab that would be very cost effective and could go ahead and establish a permanent base on the moon like so many people want to do. And yet, following that, could be revenue generation that would get the moon off of NASA's budget to free it up for Mars. So that's the concept. As I mentioned, I believe that we should go to the moon and Mars simultaneously, and I think there's a budgetary way of doing that without really significantly increasing NASA's budget. I do not support the Deep Space Gateway. I'm concerned that we're going to get trapped in lunar orbit like we've been trapped in low Earth orbit for so long. And there's a real danger that that's going to happen. I don't think we need this for the moon. And Dr. Zubrin, you know, he says we don't need that to go to Mars. It hasn't been in previous architectures. Do we need it now? I don't believe it. I believe that we should, so the question of the volatiles on the moon, the ice on the moon, should that be used for propellant from Mars? I'm against that, even though I'm for harvesting ice on the moon for propellant. Rather, it should be used to lower the cost of access to the moon, to make that more cost effective. But as you'll see, I do not think it's a cost effective way of going to Mars. Actually, I'll explain. And then I think that we can go ahead and move into a period in which we establish a permanent base, not on the moon, for the sake of the moon, not just to learn about how to go to Mars and abandon anything on the moon while we then go to Mars. We should do both, because both destinations are legitimate. Okay? Let's talk about the Deep Space Gateway. Show of hands, how many have heard of Deep Space Gateway? Practically all of you. So we are moving on this path. NASA came out and showing the different milestones for doing this. This would be in sort of a rectilinear orbit. And it's being purported to do two things. It's to sort of give us a place where we can maybe get some experience before going on to Mars. It's not too bad an idea to be outside of the Earth's magnetosphere. But then the idea is, oh, then this thing could also be used to go to the moon and help commercial and international partners to go to the moon. And I'll explain why that's such a bad idea. Okay, imagine a relay race, okay? You have a baton, you hand it off, one runner hands it off to the other, okay? The baton is a payload. The first runner is the vehicle coming from the Earth. The second vehicle is a lunar ferry, okay? So it's sort of like this. This is launched from Earth. You got the lander, you got cargo module, and you have a reusable lander that's being refueled from lunar resources. It comes up. Here's the baton, connects. The vehicle coming from the Earth disconnects, and the cargo is brought down to the moon. Okay, you could do the same thing with a crew module. Okay, the question is, do you need a deep space gateway to hand a baton off? Do you need a middleman who receives the baton from one, collects all these batons, and then hands it off? Or can't these two vehicles just dock with each other? So I don't see the need for a deep space gateway to get to the moon. Rather than a deep space gateway for the moon, for lunar development, I believe that we should have a Falcon Heavy based architecture and not an SLS based architecture. Because if we go down this route, we're going to keep consuming billions of dollars, frankly tens of billions of dollars, for a long time. Okay, we should get started with a more cost-effective approach. The question is Falcon Heavy capable enough? Yes. With the right architecture, the right lander, cryogenic lander, you can deliver 10 tons to lunar surface one way, starting with telerobots, and then with telerobotics, you harvest the ice so that it's able to come up and dock with a vehicle, another Falcon Heavy cargo, that's now delivering 20 tons to EML-1, and then it can bring it down. And that means that each Falcon Heavy launch could launch as much as an SLS Block 2 and get it to the moon, if that makes sense, okay? The lander is not going to be a SpaceX lander. This needs to be a Hydrolox, hydrogen and liquid oxygen lander, and United Launch Alliance has this in their plans. I think they and other such companies should be funded to develop these, and it can be developed for less than $400 million, less than the Falcon 9, because this is easier. Doesn't stage, doesn't go through Max-Q. The public-private programs, we're talking COTS, commercial cargo, and commercial crew, has started out at like 1 or 2%. It's now got up to 5%. It's pretty much been sustained at 5% per year. And yet we've gotten Falcon 9 first stage, upper stage, Antares first and second stage. We've got 2.5 capsules, one half a plane. And because SpaceX was one of them that's funded, we're now getting reusability and Falcon Heavy for free, okay? All of that for 5% of NASA's budget. I'm saying it's worked so well, let's do it again, but now let's go ahead and develop a transportation system from low Earth orbit to the lunar surface and back. Okay, the Deep Space Gateway. The arguments for it are that you can practice doing low latency telerobotics or telepresence by going to the gateway and doing it on the moon. Well, frankly, you can do that from ISS to the moon, or you can just do it to the Earth, or you can just do it, program in a 3-second time delay and get the experience. I don't think we need to be spending billions of dollars to get that experience. This is perhaps the most legitimate thing, and that is the biggest concern, and that is even for a flyby mission of Mars, you got to make sure your equipment doesn't, that you can fix it if you're on a long duration mission to Mars. I'm open-minded that maybe we need to be having 2.5-year missions in cislunar space to make sure that we've got all that worked out before we send people on trans-Mars injection, hoping them the best, okay? So this might be legitimate, but the question is, do we actually need to have Deep Space Gateway, or can we actually assemble a Mars vehicle and push it on out and not have this intermediate step of the Deep Space Gateway? To get going to Mars, a flyby mission would be about 590 days. That is within very close to what Polykov, the Russian, has done already. So I don't think that's a showstopper at all. The radiation is a concern, but if you position the crew with the water-bearing provisions around them, you can significantly reduce the radiation and easily keep them within their career limits for galactocosmic radiation. Okay, so what is the right path to Mars? Here's my proposal. Here's what I think we should do. I think we should do it in 3 steps. The first, as soon as we can, I think we ought to do a flyby mission of Mars. I think we ought to try to accelerate the path to Mars by seeing how quickly can we do that in a reasonably safe sort of way. Step 2, I actually think that going to the moons of Phobos and Deimos is a good idea. That mission is 2.5 years, like a full round-trip mission to Mars and back, but it doesn't require the landers. So it's a nice intermediate step, and I don't know about you, but I think that looks cool. I think that is inspiring. To circumnavigate Deimos with a jetpack, a rocket pack, I think, I would vote for my tax dollars to be used for that. I don't know about you guys. I think that'd be cool. And then the third step, which is actually sort of 2 parts, is to go ahead and first land a cargo vehicle that's sized for crew and be able to produce return propellant. And then after that's proven, you can do EDL, then go ahead and send crew. From my perspective, I did a paper for AIAA, presented it, and I think that we ought to be able to extend crew stay on the moon and Mars to where you can use some biomedical criteria to determine whether you need to come back in the first Earth return window or if you can afford to stay. Okay. Well, that was the flyby sound, I guess. So going to Mars, flyby, an Inspiration Mars sort of thing, sort of minimalist but sufficient for reasonable safety. It addresses the big concerns that we have that maybe paper dragons. This is becoming distracting. I apologize about that. And so if we can do a flyby mission, it will give us good confidence that we can handle these things. Again, Valery Polykov spent 437 days doing a Mars 2021 flyby. I don't think we're going to make that date, but it would be 74% of the microgravity, 16% of the radiation exposure. And again, this can be significantly reduced with either polyethylene or water or some other materials. Do we need to tether and spin up? To me, this is just the simplest sort of solution. You can get to 1G. I think in a flyby, I don't think you even need to do this. I mean, but perhaps on the longer missions, we might want to consider this. And then going to Mars, step 2, the Phobos-Deimos mission. I think there is an architecture to be able to have sort of minimum propellant requirements for doing that. I advocate actually visiting both on the same mission. I think that's doable. Now, when the crew is on Phobos, I think that they should teleoperate rovers on the surface, but not doing science. Rather, I think they should be operating telerobots to set up a habitat just like we have set up on the moon. And what that does is this mission commits us to going all the way. We haven't been to Mars, even though we've been to Mars distance, but it forces us to take that last step, which is actually sending people to Mars, because after all, those guys set up the habitat on Mars from Phobos. And traveling between the moons, very minimal delta V difference. Okay, and then going to the surface of Mars, lander, as I described, with cargo and propellant production first, and then crew. And yes, it could be an international mission. And then moving on to establishing a permanent base, I think most everybody's agreed that we should not just do the flags and footprint. I advocate establishing a shielded habitat and then build up a base that will turn into a settlement. Okay, what about this lunar ice for Mars propellant? Okay, I advocate lunar COTS, which is just a term for public-private program to establish a permanent lunar base. And there's different components to that which I will not get into at this time. But here's a point, and that is if you're producing propellant on the North or South Pole, it is most cost effective for the very last leg, the chemical drop from low lunar orbit to back. If you're trying to send it to EML 1 or 2, you're going to be spending some propellant to get up there, therefore it costs more to send it up here. So then the question is what cost? You could also aerobrake it and send it back to low Earth orbit and to use the propellant from there. But it gets more and more expensive the further away from the source, from the moon that you get, and it gets less expensive to deliver it from the Earth, and then it becomes more expensive as it's going out this way. So at some point, there is a point in which it's more cost effective from one source or the other, okay? But let's take a look at this. Don't hold me to these numbers, but thank you, very rough. Falcon Heavy, say $135 million launch. If you launch 7 of them a year to give you about 200 tons to EML propellant, over a period of 10 years to get sort of return on investment, that would cost you $10 billion to deliver that, okay? Evolvable lunar architecture, estimated $50 billion to be able to start providing that from the moon. That's why I don't support propellant production from the moon for Mars, because it costs more, at least early on. But if we're going to the moon anyhow, and we are developing it for the moon, then yeah, it'd be a value-added sort of thing. So the experience, I think EDL is very different between the two. I don't think there's much benefit. ISRU is fairly different. The atmosphere is much easier to access than lunar ice. Habitation systems would be quite similar, practically the same, I think. So there would be some value there, but I don't know that we actually need to do it on the moon to have confidence in the systems before we go to Mars. The development paths, interestingly, would be very similar for both the moon and Mars, in that we develop a transportation system. I advocate having commercial crew be the first people on the moon and even on Mars. And they focus on lowering the cost for the transportation system for everybody else. And then a phase of suborbital exploration on the moon and Mars. That's the second phase. And I think that the companies providing the transportation for all sorts of countries doing exploration on both planets would help to transition off of NASA's budget. And then moving on, the more transportation you have, the more cost effective it is, and you move on to settlement. So is the moon a stepping stone to Mars? I would say by and large, no. That's my position. I think that we should do the Mars flyby first. I think that we should go to next Phobos Deimos. You don't really need to go to the moon to do those things. I think that the two destinations are both legitimate for their own purposes, and that includes settlement for both. There's enough volatiles on the moon to sustain a city of 1 million people that recycles its carbon, nitrogen, its water for about 1,600 years before they had run out of the volatiles on the moon. And in that 1,600 years, you can easily develop systems of bringing in water from asteroid sources. So here's my plan to influence space policy. So this is, I'll tell you now, it's a Hail Mary. I have been doing all sorts of things. Speaking at conferences, I've done my own lobbying. I've emailed and called and met with all sorts of people trying to urge lunar COTS, cost-effective development of the moon, and to leave space for going to Mars. So Falcon Heavy this is the thing that I'm going to try to advocate. Falcon Heavy should be America's moon rocket. If we can do that, we've got money for Mars. This is a concept that I have, and this is United Launch Alliance's lander configuration. This is sized to go on top of the Falcon Heavy. So when the Falcon Heavy launches in early November, I plan on being near Port Canaveral to set up a full-scale lunar lander inflatable to mock it up to show what would this thing look like. And then I want to email every space and science journalist and say, when you write it up, say that this could be America's moon rocket. This is a picture I took 2 days ago. Just finished it. My high school gym. We've actually got this thing built and ready to ship. So that is my plan. So, okay, and after I get done with that, I'll be working in Tucson to establish a Moon-Mars analog base to sort of simulate the development aspect of space settlement. So my appeal is to you guys is Mars advocates. I think it's to your distinct advantage to make sure that we do lunar development in a cost-effective way, not an expensive way. And as I try to reach out and make the case of developing the moon in a cost-effective sort of way, it would help if some of you would join me in being able to contact decision makers, and I can help you do that, of saying, hey, I'm a Mars advocate. I advocate going to Mars. I'm concerned that if we go to the moon in an expensive sort of way, it's going to really hinder space development. I think that we should look at Falcon Heavy as being America's moon rocket. Okay, thanks. Yeah, back there?
So a couple of thoughts for your consideration.
Sure.
The delta V to get into low Earth orbit is approaching 9 kilometers per second.
Right.
The delta V to escape from the moon is about 2.2 kilometers per second. So it's about 15 times or more energy to get propellant from the Earth to low Earth orbit than it is to get from moon to the top of the Earth-Moon gravity well. Second point, the best place to refuel a rocket on its way to Mars is the top of the Earth-Moon gravity well, because the delta V to get there from there to Mars is much less. Third, getting from the moon to low Earth orbit is relatively easy because you can aerobrake.
Right.
Fourth, we have 3 rockets that don't exist right now: SLS, Falcon Heavy, and New Glenn. From an architecture perspective, only one of them is elegant: New Glenn.
Right.
So consider that as a commercial. The other thing is public-private partnership doesn't work without competition. If you pick one now, it'll cost 10% less than SLS, because that's what private companies do without competition. So you have to have Blue Origin, SpaceX, and maybe one other competing in order to get the economic benefits of commercial approaches. So very interesting presentation, but I wanted to put some data on the table that might say another thing about the approach. Elon Musk has talked about mining permafrost on Mars. It makes no sense to go to Mars to mine permafrost when we haven't figured out how to mine permafrost on the moon first. And then one other last, you heat it. No, it's much, much harder than that. I'm in that business.
So let me just comment. I've got responses to you. You mentioned about 5, 6 different things. I've got responses to each of those.
Okay.
It would be good to continue this conversation.
I just wanted to put that on the table for
Right.
consideration.
Any other questions before we move on to the next session?
Yes. When you go to Mars, what's the likelihood of putting any kind of permanent presence on either one of the moons to use them for relay stations, for Mars GPS, or it seems I've heard that there's not too many assets that we have currently orbiting Mars to support all of the communications and everything else that would be needed in the long run. So could some of that stuff be taken?
So just a quick response. This is my opinion. I think that probably it makes more logical sense to put them in approximately the same orbit. Put a communication. There's nothing special about Phobos or Deimos in terms of communications. I think you want to have it to where you're maximizing coverage, and so I think that means probably closer in, like our current satellites.
Last question?
Yes, one thing I wanted to add. The lunar orbit is about the same delta V as Mars orbit if you allow atmospheric braking, which is very possible if you have some intelligent control on the landing vehicle.
So my question is the Mars vehicle the most cost-effective vehicle for going to the moon? And I'm guessing probably not. Even different propellants, you know. Let's develop each in the most cost-effective sort of way. If that does come down to using the same vehicle, I'm fine with that. I'm guessing it's probably different vehicles. Yeah. Thank you for your attention.